Alright, very good day to you. So today we are going to look at a different concept. As you can see here, we have three different diagrams, plenty of lollies that you have on this particular slide here. So towards my left, you will see there's a lot of what we call jelly beans. You probably come across jelly beans when you go to Coles or Woolies. There's plenty on the aisles. If you go to the diagram on the right, top right of the diagram, you have Skittles, the very famous Skittles. And then the bottom right, you have Sour Patch. So if you have consumed some candies, they are very sourish, probably it is a Sour Patch. So what we are going to look at for today's lesson, you see there's a lot of different colors, you said there's a lot of different tastes. And then let's just say that you look at the jelly bean, for example. And then if you look at something that is red, you know that most likely is of apple flavor. If it's yellow, it could be a lemon flavor, white vanilla flavor. And if you look at green, for example, you can probably get, let's just say, lime or kiwi fruit. So my point here is that now the question that I have is, what do you think these flavors are? Are they natural or are they artificial? So a long time ago, when we are trying to create food that has taste, that has different type of taste, they usually use the pure products. So let's say they get it from fresh fruits, and then they get the juice of it, and that's how they manufacture food that has different taste. But nowadays, if you look at lollies, for example, they actually use what we call an artificial taste. So the question, or the next question that you probably have, how do we create artificial taste? So there is something that is known as ester, which is a chemical that we can generate in the lab, and it can imitate the taste or the flavor of the natural products, even though they are not natural. So once again, if you look at, let's just say, Skittles or the Sour Patch, for example, if you taste something that has a very similar taste as, let's just say, lime or lemon, or apple, for example, or even oranges. You know that some of these lollies is orange in color. They'll be like, oh, it is an orange. It could be from the real oranges, but that's not true. Or some of them could be, but most of them are not. So there is something that we are going to do. So what are these chemicals? How do they look like? And by the way, my favorite out of the jelly bean here is probably Dr. Pepper. So if you have tried some of these flavors, go ahead and try it, and you can taste it for yourself. They taste like the real deal, all right? But even though they are not natural. We're on to the next slide. All right, here. So we have these different diagrams. As you probably know what I'm going to mention next. If you look at this pineapple, banana, and you have orange, for example, you know that the flavor or the taste in those lollies that you have seen before are artificial. So if you look at pineapple, for example, there is a compound known as ethyl butanoid. If you look at pineapple, for example, you have something known as pentyl ethanoid. And if you look at orange, you have something that is known as ethyl ethanoid. So my point here is that all of these compounds ends with OATE, OATE, that we are going to discuss in a short while, and these are what we call chemical compounds. They can be synthesized in the lab to actually imitate the actual products. And they are usually used in the production of, let's say, lollies or candies, and even the mint flavor. You look at some of the candies, it's like mint flavor, that can also be manufactured in the lab as well. So moving on to the next slide. Alright, so we are looking at formulas and structures of acids. So how does an acid look like? So it says here, and I'm going to highlight this for you, and it says that an ester functional group consists of carbonyl group with a second oxygen bonded to the carbon atom to form COO. It says the general formula of an ester may be represented by RCOOR', where R and R' are alkyl group, which may or may not be identical. So esters are formed when carboxylic acids are heated with alcohols in the presence of sulfuric acid. So the combination of alcohol and carboxylic acid will enable you to get what we call an ester product. So it says the sulfuric acid acts as a catalyst, and it actually speeds up or increases the rate of reaction, but it's not consumed by the reaction itself. So once again, what you need to focus here is that you have a reaction between alcohol and carboxylic acid. When it's combined with the presence of sulfuric acid, you're able to produce what we call an ester. So an ester is a formula that basically combines that carboxylic acid and the alcohol compound. So moving on to the next slide. Alright, so if you look at this diagram here, towards your left, you have this carboxylic acid. How do we know this is carboxylic acid? You can see that it contains the carboxyl group. Can you see that? It contains the carboxyl group, COOH. And if you look at the second diagram, this is what we call, so make of 3 carbon, propanol, and because it's an alcohol, so it ends with O. And if you look at this diagram here, I'll highlight this in green, it consists of 3 carbon. So with the presence of sulfuric acid, which is the catalyst that speeds up the reaction, you will see that these 2 different compounds will join together to form, in this case, what we call an ester. And the ester that is being formed is propyl ethanoate. So it consists of 3 carbons towards the right of that particular structure. And I'll draw this structure for you. So if I circle this, it looks something like this here. So towards the right side here, we have the alcohol. The alcohol component is now being joined. So I will put it as green so that you know what I'm talking about. So that is of 3 carbon. And then you have the carboxylic acid, which is the ethanoic acid. It consists of that 2 carbon. And together, it forms propyl ethanoate. And then it releases water molecule as well at the same time. So water molecule is being released as a product. At the same time, you do have your propyl ethanoate, which is the ester that is being produced. Moving on to the next slide. Alright, so what is an example of an ester? So it says that the name of the ester is made up of 2 compounds that react to form the ester, an alcohol and a carboxylic acid. It says example of an ester is methyl ethanoate, which is formed by the reaction of ethanoic acid and methanol. So if you look at this diagram on your right, and the top right, you have what we call a ball and stick structure. So the one in gray shows the carbon, the one in red shows the oxygen, and the one in white shows the hydrogen. So if you look at structure at the bottom here, this is what we call the structural formula. So the one that bottom right of your diagram. And I'm going to highlight this in yellow so that you know what I'm talking about. My apologies that part of the diagram is being blocked, something that I'll bear in mind when I create further lessons. So for now, if you look at that structure, it consists of 3 carbon. One of the carbon comes from the alcohol, which is methanol, and then the other 2 carbons come from ethanoic acid. Ethanoic acid consists 2 carbon. So you have 1 carbon which is towards the right of the structure. So if you read from the right hand side of the structure, you have that 1 carbon. On the left hand side of the structure, you have that 2 carbon. Together, you will form what we know as methyl ethanoate. Moving to the next slide. Alright, so now it's talking about naming an ester. How do we name ester? It says the name of an ester can be determined using the following steps. Locate the functional group and the carbonyl carbon. Starting from this carbon, determine the number of carbon atoms in the chain attached to it. Name it according to the stem name, adding the suffix OATE. This carbonyl containing portion of ester is derived from the carboxylic acid. It says the alkyl group bonded to the singly bonded oxygen atom is then added in front of the name. And this portion of the ester is derived from the alcohol. Alright, there's a lot of words there. What I will show you, and this could be easier for you to understand. Alright, so this particular slide here may be easier for you to understand on how to name the ester. So it says that the name of the ester can easily be determined if you know the names of the carboxylic acid and alcohol that it's made from. It says the alkyl group name is derived from the name of alcohol. For example, methanol becomes methyl or methyl, depending on how you pronounce it. And the oil acid portion of the carboxylic acid name is replaced with OOAT. For example, ethanoic acid becomes ethanoate. The name of the example ester would be methyl ethanoate. So when you're doing your naming, the first part of the name is from the alcohol component. whereas the second part of the particular naming is coming from the carboxylic acid. So in this case, the carboxylic acid is the ethanoic acid, so ethanoic acid becomes ethanoic, whereas the alcohol component will become methyl. So you have methyl, ethanoic, methyl, ethanoic. Alright, so alcohol comes first before the carboxylic acid. Alcohol comes first before the carboxylic. But bear in mind, when you're drawing the structure or the molecular formula, you have to put the carboxylic acid first before the alcohol component. Alright, I'll show you some examples in the next few slides. So let's just say we look at this particular example here. So they ask you to name the systematic name. So this is based on the IUPAC name. You probably have heard of this before when we talk about International Union of Pure and Applied Chemists, that particular system in terms of how we name different structures. So if you look at this particular molecule here, on this diagram, and I will highlight this in green, which is the one that is coming from the alcohol component, and the one in orange is coming from the carboxylic acid component. So what you will see here, ultimately, when you are naming, it's sort of like the opposite. You will name the alcohol first, or alcohol components first, before you name the carboxylic acid component. So in this case, the naming that they've given at the bottom is ethyl propanoate. So ethyl, that ethyl is coming from the alcohol. So in this case, the alcohol consists of 2 carbons, is of ethanol, and then the carboxylic acid components is of 3 carbons, which is propanoic acid. Together, it will form ethyl propanoate. So when you're drawing the structure or the molecular structure, you draw the carboxylic acid and then you draw the alcohol. When you're naming, you name the alcohol before the carboxylic acid. So in this case, it's known as ethyl propanoate. I'll show you the next slide. Alright, so this one here, properties and uses of ester. There is a question on the textbook, and then we'll discuss more of that question in class as well. So it says here, properties and uses for ester. Although esters are polar, they have no free hydroxyl group, so they cannot form hydrogen bonds with each other. It says as a result, esters have a lower boiling points than carboxylic acid and alcohol of similar relative molecular mass. Something for you to think about. So when you are talking about your ester structure, and based on what we have discussed previously as well, it consists of the first part is of the carboxylic acid, the second component is the alcohol component. And I did mention that it's combination of both. Before this, we say the alcohol by itself can form hydrogen bonding, carboxylic by itself can form hydrogen bonding. But when you're putting both carboxylic and alcohol together to form ester, ester cannot form hydrogen bonding. Why? Because it doesn't have any lone pair electrons. When you look at the structure, and if there's a time in class, I'll go through the structure. If you look at the structure, it doesn't have lone pair electrons, and that is a reason why it cannot form hydrogen bond. And you can see based on the boiling point, can you see the boiling point of ester is significantly lower than the boiling points of alcohol and carboxylic acid? Can we see that? And that's true because it is not able to form hydrogen bond, which means that in terms of its polarity, is significantly weaker than alcohol and carboxylic acid. Alcohol and carboxylic acid, they are also polar. All 3 of these compounds are polar. The difference between them is that carboxylic acid and alcohol can form hydrogen bond, and you have alkyl ethanoate that cannot form hydrogen bond. So even though all of them are polar, alkyl ethanoate can form dipole-dipole. Whereas carboxylic acid and alcohol can form both dipole-dipole and hydrogen bond. That is the reason why the boiling point of carboxylic acid and alcohols are higher as compared to the ester. In this case, the ester is alkyl ethanoate. So as compared to the ester. Move on to the next slide. Alright, so we're going to look at the structural isomers of ester. When we're talking about structural isomer, we're talking about the molecules with the same molecular formula but different structural arrangement. Same molecular formula but different structural arrangement. So we have looked at alkane, alkene, alkyne, alcohol, carboxylic acid, all of them. For some of these structures, even though it is of the same molecular formula, but the structural arrangement is different. And if it's different, you get what we call a structural isomer. So it says that these esters are structural isomers of one another with a formula of C5H10O2. C5H10O2. Can you see that all of these 3 structures here, they actually have 3 carbon? I will highlight this in orange for you. So even though the number of carbon on the carboxylic acid, which is the one on the left, so when you're drawing the structure, the first part of the structure is of carboxylic acid and the second part is of alcohol. You can see that the first part and the second part actually changes depending on the structure that we have. So if the first part has 3 carbon, which is the first diagram, so you look at the 3 diagrams, the one at the top. If it's of 3 carbon, it consists of what we call propanoic acid. So propanoic acid and ethanol, when it comes together, we get ethyl or ethyl propanoid. If your carboxylic acid is of 2 carbon and the alcohol is of 3 carbon, you get propanethanoid. Propanethanoid, bear in mind, when you are doing the naming, you must always name the alcohol first before the carboxylic acid, something for you to think about. And the third diagram is the diagram at the bottom. Towards the left of the diagram, you have 1 carbon. Towards the right of the diagram, you have 4 carbon. So in this case, the alcohol is of 4 carbons. So you have butamethanoid. Butamethanoid. So you name the alcohol first before you name the carboxylic acid. But bear in mind, when you're drawing the structure, you must always draw the carboxylic acid first before the alcohol. So there is a swap in terms of the structures and the naming. So make sure you are very clear on this, and all of these actually has the same molecular formula with C5H10O2. Alright, so something for you to think about. And that means that our lesson on ester is completed. So I will see you soon in the next lesson. Any question, feel free to email me, and then I'll see you soon.